one.
Hello, I'm Micah.
Hi, I'm Yusuf.
And we made WindSense, which is supposed to be an interactive fan that interacts with the environment. Um, this is the general concept of where you have this fan that's on a bus stop, and it will interact to the environment via sound, movement, and humidity and temperature. Um, and this is the general concept that we came up with. We had it where you would have a fan and motor, of course, turn on when it detects a certain temperature. So it would automatically turn to a specific percentage. If it detects a person coming in or moving, it would turn on, given that it's at a certain temperature and such. And if someone were to say it is too cold, then it would shut itself off. Or if they said, "Oh man, it's really hot out here," it would turn itself on. That's the general concept.
So how we aimed to achieve this was first using the ESP8266 microcontroller running a local computer vision model, and we tried to get it running locally for privacy reasons, but also for quicker compute times, like compared to APIs. And then that would, over Wi-Fi, because we're in two different locations, me and him, it would send the data over Wi-Fi to an MQTT server, and then his microcontroller with the fan attached would then detect the classification that we assigned to it, and turn on the fan basically. And so the entire system worked except the final link, which was just getting the MQTT server to connect to his microcontroller. But otherwise, his endpoint worked with the fan, and then I was able to get my AI model to send to the MQTT server and then send from the MQTT server to his computer.
Yep. And that should be end of the recording.
So I can take raw features from this image. So then you load these features over here, and then this will do the inference and then also send to the MQTT server.